For as long as humanity has existed, we've gazed at the night sky, filled with wonder and curiosity. In the quiet moments of our most profound thoughts, we ask the questions that have long eluded answers. Where did we come from? What is the story of the stars, the galaxies, and the universe itself? And most tantalizing of all, are we alone in this vast, infinite cosmos? Our search for these answers has been guided by an extraordinary tool, the Hubble Space Telescope. Launched in 1990, Hubble became humanity's most powerful window into space, offering up images of galaxies millions of light years away, distant stars being born, and nebulae glowing with vibrant color. It took us places we could only dream of, changing how we see the universe. But space exploration, like human knowledge, is a constantly evolving journey. The James Webb Space Telescope, or JWST, has been designed to carry us even further, to explore the depths of time and space in ways Hubble could never do, revealing not just what the universe looks like, but how it came to be. The JWST is not just a telescope. It is a time machine, capable of peering into the very birth of the universe, a billion years before Hubble's view. But what makes it so special? And what sets it apart from its legendary predecessor, Hubble? To answer that, we must dive deeper into the extraordinary features of the James Webb Space Telescope and explore how it will push the boundaries of what we know about our universe. The dream of the James Webb Space Telescope began long before its 2021 launch. The journey took over 2 decades, and it was not without challenges. In the late 1990s, as Hubble continued to send back breathtaking images from orbit, the next frontier was becoming clear: a new space telescope that could peer beyond the visible spectrum into the infrared realm, where hidden secrets of the universe could be uncovered. The idea was ambitious: a telescope that could reach further than Hubble and unlock new dimensions of space exploration. Its mission: to study the universe's earliest galaxies, its stars in their infancy, and the birthplaces of planets, including those that might harbor life. But to achieve this mission, scientists and engineers would need to create something truly unprecedented: a telescope that could survive in deep space, a million miles away from Earth, equipped with technology never before seen in a space observatory. It was an extraordinary challenge, one that would require cutting-edge engineering, advanced materials, and a deep understanding of space. The final product: a telescope with a gold-coated mirror the size of a tennis court, highly sensitive infrared instruments, and a sunshield the size of a basketball court to protect it from the sun's heat. A massive, highly complex structure that could fold itself into a rocket and unfurl into the universe once it reached its final orbit. This is what the James Webb Space Telescope is made of. After years of meticulous design and testing, JWST launched on December 25, 2021, aboard an Ariane 5 rocket. A month-long journey followed, one of uncertainty and excitement, until the telescope reached its destination, the second Lagrange point, L2, where it would settle into orbit. Here, it has begun its mission to unlock the mysteries of the universe in ways Hubble never could. But before we look ahead, let us pause and reflect on the remarkable legacy of the telescope that laid the groundwork for this new chapter, the Hubble Space Telescope. When it was launched in 1990, Hubble was hailed as humanity's greatest tool for peering into the cosmos. Positioned in low Earth orbit, Hubble was free from the distortions caused by Earth's atmosphere, enabling it to capture breathtaking images of the universe in unprecedented detail. It gave us iconic images, like the Pillars of Creation, the Hubble Deep Field, and countless others. that have shaped our understanding of galaxies, stars, and the very fabric of space-time. Hubble's impact was monumental. It helped scientists measure the rate of the universe's expansion, discover distant exoplanets, observe the birth of stars, and peer into the depths of the universe's most mysterious phenomena. It revealed wonders we could never have imagined, all from its humble position orbiting Earth. But as powerful as Hubble is, its view of the universe is limited. The telescope primarily observes visible light and ultraviolet radiation, wavelengths of light that are blocked by cosmic dust and gas. While Hubble gave us a stunning image of the universe in visible light, there were entire regions, events, and phenomena that it simply could not capture. And that is where Webb takes us to the next level. So what makes the James Webb Space Telescope truly unique? The answer lies in the telescope's revolutionary infrared capabilities. Where Hubble looked at the universe through visible light, JWST will explore the cosmos in a way no telescope ever has before by observing the infrared spectrum. Infrared light is what we use to see the heat emitted by objects. This is crucial in space, where many of the universe's most interesting and fundamental processes unfold beyond the reach of visible light. The cosmic dust that obscures our view of newborn stars, the birth of new galaxies, and the formation of distant planets is transparent to infrared light, allowing JWST to peer through this dust and reveal hidden phenomena that Hubble could not. Even more exciting, infrared light allows us to observe objects so distant that their light has been stretched out by the expansion of the universe, shifting their light into the infrared. This allows Webb to study the first galaxies, formed a mere 200 to 300 million years after the Big Bang, much further back in time than Hubble could see. The technology that powers the James Webb Space Telescope is nothing short of awe-inspiring. At its core is the primary mirror, a massive array of 18 hexagonal segments, each coated in a thin layer of gold to optimize the telescope's ability to observe infrared light. Together, these segments form a mirror that is 6.5 meters across, almost 3 times the size of Hubble's. This giant mirror allows JWST to collect far more light than Hubble, enabling it to observe much fainter, more distant objects. But size alone is not enough. JWST's true power lies in the precision engineering behind its design. The segments of the mirror can be adjusted with incredible accuracy, allowing JWST to focus its instruments with unparalleled clarity. To protect the telescope's sensitive instruments from the intense heat of the sun, JWST is equipped with a sun shield, a 5-layer, tennis court-sized structure that keeps the telescope cool and shields it from the solar radiation. Without this sun shield, JWST wouldn't be able to operate in the infrared, as the heat from the sun would interfere with its observations. It's a brilliant piece of engineering, designed to protect the telescope while keeping it in the perfect conditions to study the universe. With its advanced instruments and infrared sensitivity, the James Webb Space Telescope is capable of answering some of the universe's most pressing questions. JWST will peer into the early universe, studying galaxies formed just a few 100 million years after the Big Bang. These galaxies will reveal the secrets of how the first stars were born, how galaxies evolved, and how the universe's structure began to take shape. But Webb doesn't stop at the distant past. It will also study the birth of new stars, hidden in dense clouds of gas and dust that even Hubble couldn't penetrate. It will explore the atmospheres of exoplanets, planets orbiting other stars, in the search for signs of habitability or even life. With its infrared capabilities, JWST will provide the clearest view yet of these distant worlds and their potential to support life. The James Webb Space Telescope isn't just a new instrument. It is the future of space exploration. With its ability to look back in time and observe the universe's earliest moments, it promises to reshape our understanding of the cosmos. It will help us unlock the secrets of the first galaxies, the birth of stars, and the potential for life beyond Earth.